Hi everybody, this is your part 2. We're going to see what is standard normal distribution. That is, by the end of this week, you should be able to transform a normal distribution to a standard normal distribution. You should be able to read a Z table and use it to identify and find the probability of a given area under a normal standard distribution. Okay, so we have seen that a variable x that follows a normal distribution with a mean mu and standard deviation sigma can be stated as x, that is, x is a random variable from the population that follows a normal distribution with a mean mu and standard deviation sigma or variance sigma square. Okay, we have been finding how far x is from its mean in terms of its standard deviation, isn't it? What we have been doing so far to find the area under a normal distribution curve. What were we doing? We were trying to find how far x is from its population mean in terms of its standard deviation, isn't it? Actually, we were calculating it by finding x minus mu by sigma. And what is this? This difference between the random variable and its mean, population mean, divided by the population standard deviation. It is nothing but z, and z is nothing but, we call it a standard score. So standard score, z, helps us to transform x into, this formula helps us to transform x into z. Yeah, and why do you need to transform this? Because this will help us to sketch a standardized normal distribution for a given normal distribution. A standardized normal distribution is very useful for two good reasons. It helps you to calculate the probability of how likely a variable x occurs within our normal distribution, and it helps us to compare two scores that are from different normal distribution. Okay, you may ask me, we can use the normal distribution to calculate the probability. Yeah, yes, you can, but the method is quite complex. Yeah, it is easier to transform this normal distribution into a standardized normal distribution and then find the probability. Yeah, so that's what we're going to see with examples. And a standardized normal distribution will help you compare any two scores which belong to two different normal distribution. As you have seen that the area under a normal distribution, any normal distribution, is the same. The percentage of data in a certain area is same. We have seen that. That is one of the property of normal distribution. So that is why by standardizing the normal distribution, by converting this normal distribution into a standard normal distribution, how are you going to do that? Using this transformation formula, that is standardizing this normal distribution into standard normal distribution, you can easily calculate the probability of how likely a variable x occurs within our normal distribution. Okay, let's see one more thing. Yeah. Okay, if x is to the left of the normal distribution, that is, if x is less than the population mean, it is on the left, okay, then z will be a negative number of the standard deviation, because then x will be negative, minus minus, so z is going to be negative. So all the values of z on the right of the mean will be positive, all the values of z on the left of the mean will be negative. We will see some examples to understand this more clearly. Okay, so you can use this transformation formula and convert the normal distribution into a standard distribution like this. So each value of x can be used to convert this into this. Yeah? And that standard normal distribution is stated as follows. So Z is a standard score from the standardized normal distribution with a mean mu 0, with a mean 0 and standard deviation 1. So mean is 0, standard deviation is 1. Okay. Now, let's go back to the cholesterol example where the population mean was 5.5 units and standard deviation was 0.5. That means at the first standard deviation, the value is going to be, oh no, that was 5.0, sorry. It will be 5.5. And at the second standard deviation, it's going to be 5.5 plus 0.5 is 6, okay? Similarly, on this side, it's going to be minus, and this is going to be 4. So if I substitute this in this formula to find the corresponding z-score, so for 5.5, let me take this first. For 5.5, I substitute x is equal to 5.5. What is the population mean for this example? 5 units, yeah. Sigma is 0.5. And if I calculate the z value, it's going to give me 1. So look at that. The corresponding value is for 5.5 is what? If I substitute 4.5 here, I will get 4.5 minus 5. So that's going to be minus 1 now. If I substitute 4.5, the z value is going to be minus 1. Look at that. So the corresponding value is minus 1. So you can convert each value of the random variable to a z-score. Yeah. So the corresponding distribution will be standard normal distribution. So you can convert a normal distribution into a standardized normal distribution using this transformation formula. Agreed? So you can convert a normal distribution into a standard normal distribution using the transformation formula. Okay. And the total area under the curve is 1, because the total probability is always 1. Okay. So in summary, any normal distribution can be transformed into a standard normal distribution using this transformation formula. Remember, here for the standardized normal distribution, the mean is always 0 and the standard deviation is always 1. It's 1. 1. So standard deviation is, okay. Here the standard deviation is sigma. Okay. So that is the difference. And why do you need to standardize a normal distribution? Because it is easy to find, helps you find the probability under the curve in a given region, and it helps you to compare two different normal distributions. We will see lots of examples in the seminar. So Z is simply a measure of how many standard deviations a value of X is from its mean. So for our cholesterol, the population mean was 5 units and the sigma was 0.5, which means at first standard deviation you had 5.5 units. So corresponding value was 1 standard deviation. So it clearly shows that 5.5 is 1 standard deviation away from the mean. It is just a measure of how many standard deviation a value is from its mean. So you can clearly see the relationship. And the area should be always 1 under the curve. Okay, now why do you need a standard normal table and what is a standard normal table? So we're going to see that now. So just like the empirical rule for a normal distribution, the same rule follows for a standardized normal distribution. Okay, so 68.2% of data will lie between plus or minus 1 standard deviation, 68.2%, and 95.4% of data will lie between the plus or minus 2 standard deviation. It's the same rule which holds under a standard normal distribution. Okay, the probability of Z less than 0 will be 0.05. From this empirical rule, we can clearly see that. So probability of finding z less than 0, that is this area, is nothing but 0.341 plus 0.136 plus 0.023, which is nothing but 50. Or you can also say that this is a symmetrical data. So 50% of the data is a symmetrical data. Yeah, 50% of the data lie below z less than, below z is equal to 0 or z less than 0. Similarly, if I ask you what is the probability of finding z less than -2, that is, you're interested in this region, you still can use the empirical rule to find the percentage. Yeah, which is 2.3%. Yeah. Okay, now if I ask you, so sorry. So enables us to find the probability of getting x in a specified range. Yeah. So now you can find the probability of any of these values, which it is easier. Yeah. What about the z values that are not -2, -1, 0, or +1 or +2? You can use the empirical formula to find any values on this using your empirical rule. Yeah. You can find all these values. Yeah. So z greater than 2, it is 2.3%. Z less than 2 is 100 minus 0.2, 2.3%, which is 97.7%. Yeah, this one. So you can clearly find the probabilities for a given range using empirical rule. But what about the values which are not equal to these values? That is, what if z is equal to 0. Z is less than, probability of finding z less than, so that should be around 0.5. This is 0.5, so z is somewhere here. What is the probability of finding z less than 0.6? This region. How will you find the probability? That's not possible using the empirical rule. Similarly, what about z less than 0.12? That means somewhere here. Probability of finding z less than, that's not possible. So then in such cases, we can use a Z table software or TI graphing calculator. And in our syllabus, we are going to stick on to Z table. We can't use the TI graphing calculator or any software. We're going to use Z table to find this probability. So for this reason, we have something called a Z table. Cumulative probabilities for all values of Z are tabulated in this Z table. So this is your standard normal table or Z table, which you're going to use to find the probabilities under a given area. And this table gives the probability to the left of the values of plus Z, positive Z, okay? So this probability can be found, this shaded region can be found using Z table. And you can see that it starts at 0, Z is equal to 0, Z is equal to 0. Starts from here. Okay, so let's see some few examples how to read this Z table. Okay, so we know that this Z table always gives the probability to the left of the values of positive Z. Yeah. So have you heard of the song To the Left, To the Left? So that's what you're going to use here, to the left. So probability of Z less than 0, less than this value, look for the value here, and that is this shaded region. This is the probability you're going to find here, Z less than 0. And then, so that's your Z value, and that is your second decimal. place, okay? So that gives you 50%. And you know that 50% of the data lies to the left of 0, yeah? And that's 0.5. Similarly, Z less than 3.49. So it should look like somewhere 3.4. You will have 2 decimal places here. So you go down the Z value, you go for 3.4. And the second decimal place is 9. You go across to 0.09. And so you go down and you come. So 3.4 plus 0.09 will give you the percentage probability below Z below 3.49, which is nothing but 99.98%. Okay. Okay. So this first column gives you the value of Z to its first decimal place, and the row gives you the value of Z to its second decimal place, and this whole thing gives you the probability of finding Z under this standardized normal distribution. Okay. Okay. So the table enables you to calculate the probability for any value of Z. Okay, so now let's take a simple example. Z is equal to 1.25, and we want to find Z less than 1.25. That is somewhere here. So it's not 1, 1 should be somewhere here. So Z less than 1.25. So you know that along the column, you go for the first 2 place. So 1.2, look for 1.2. Second decimal place is 5, 0.05. So you go around, look for 0.05. So that's just like your two-way table. Go around, go along the row, and then and you get 0.8944. So the 89.44%. So probability of finding Z less than 1.25 is 89.44%. That's your shaded area. The unshaded region, what does it give you? What does this give you? That gives you a probability of finding Z greater than 1.25. And you know that total probability is 1. So 1, this is nothing, this region is nothing, 1 minus 0.894. 1 minus 0.894, that is 1.8944 is nothing but 0.1056. And what is that? Z greater than 1.25. Probability of finding a standard score Z greater than 1.25. Okay, now over to you guys. What is the probability of finding Z less than 0.2? Good. So that means we're talking, so this is your 0 and 0.2. So what is the probability of finding Z in this region, this shaded region? Less than means in this region, shaded region, yeah? So go down to 0.2. We don't have a second decimal places. It is 0 here, so that should be your value. So 57.93%. Next, what is the probability of finding Z less than 1.9? Good. So you go down to 1.9 along this column. And the second decimal place is 0, so you look down here. And then you get 97.13%. Good. And that's how you find the probability using a Z table. Okay. Now let's see another good example. So we're going to see two different examples where you're going to find the probability when one of them is given, one of the value is given, okay? So using the transformation formula, that is transforming X to the standard normal distribution, yeah? Okay, if X is a random variable from the population and follows the normal distribution with a mean mu equal to 20 and sigma is equal to 4 square, find probability of X greater than 23. How will you do that? What will you do? You know that, you have just seen that Z is simply a measure of how many standard deviation a value of X for X is from the population mean. And you can use this transformation formula. So to find the probability, you have to transform X to Z first, isn't it? Okay, so let's find the corresponding value of Z. So we substitute X is equal to 23, 23 minus 20 by 4, and this value will be 0.7 standard deviations away from the mean. That means a random variable X is equal to 23. So let's go back. Random, so the mean is 20. So standard deviation is 4. That means this value should be 24, 20 plus 4, 28. And this should be 16. This 20 minus 4. And here you will have 12. Okay. So where is 23 lying? Maybe 23 will be somewhere here. So the question is asking you to find the value of X greater than 23. So that's 23. Okay, so somewhere here we need to find. We don't know the value, but we can say that somewhere it is here. Okay. So that's how it looks, okay? So that means now we know that it is Z is nothing but 0.75. So this value is 0.75 standard deviations away from the mean. Okay, so we know that now. That's how it looks, yeah? So therefore, the probability of getting a value of X greater than 23 is obtained from the Z table, and you look for Z is equal to 0.75. So it's got two decimal places, yeah? Two decimal places, so you look for 0.7, and then the value is 77.34. So the probability of getting X greater than 23 is 1 minus 0.7734, which is 0.226, because we were trying to find the probability. That was our mean, and that was 0.75, and we were actually interested in finding this value. And from the Z table, you can only find the probability to the left, to the left, to the left, to the left. So this probability is 77.34%. So what is this probability? 100 minus 77.34%, which is nothing but 22.66%. Okay, so this is how you find. So best way to find this, to solve a problem like this, is to draw the distribution and then calculate it. Yeah. So next, the other type of question is to find the other way. That is when you're given the normal distribution and you're given that X is less than A and this value is missing, but you know the probability. So that means your plot will look something like this. X, so that is your 0, and you know that for a particular value of A, okay, X is less than A, sorry, not that. X is less than A. So this region is 0.7611. So, and you need to find this value. So you're going to do the same way and then find the Z table. So first, let's transform this into a Z score. Yeah. Okay. So we know the value of Z. It is 76 point. Okay, I haven't put it in a proper animation. So you know the value of, ignore this, guys. So you know that the probability is, this area gives you the probability, so 76.11. So corresponding value will be 0.71. Yeah, so you substitute it here, and then you have X is A, Z is 0.71. 0.71 is equal to A minus 20 divided by 4, and then rearrange it to find the value of A. Okay, so from, you know that this is the probability as we have seen in the sketch previously. So we know that this is 76.11%. So you can use the table. Let me go back, erase it. So you know that the probability is 76.11. Use the table and find the corresponding value of Z. So once you get the value of Z, substitute here, and then rearrange this equation to find the value of A. So now you know that X is less than 22.84. Okay, so we have seen all this part 2. Now next, we're going to solve different types of probability problems in part 3.